Welcome to channel for Bible and Math. Today we want to talk about quadratic equation, how to solve quadratic equations by factoring, taking roots, uh, by using the quadratic formula and the graph, especially for quadratic inequality problems. So now let's move to approaches to solve quadratic equations. As I said, the square root rule is x squared equal k, then x equal plus minus square root k. And the factoring method, for example, x squared minus 2x minus 15 equals 0, then we can factor two binomial terms, x minus 5 and x plus 3 equals 0. Then by using a multiplication property to zeros, then x minus 5 equals 0 or x plus 3 equals 0. Then we get solution. That's factoring method. Quadratic formula, we can use quadratic formula x equal minus a plus minus square root b squared minus 4ac over 2a from a standard quadratic equation ax squared plus bx plus c equals 0. How to get the quadratic formula? We can have details in next slide, but we try to make a perfect square form by using first two term ax squared plus bx. So like x plus b over 2a square, but you use the extra term b squared minus 4ac over 4a squared, so you have to subtract that. Then x plus b over 2a equal plus minus, this term you move to the right hand side so that square root, so x equal minus move b over 2a plus minus square root b squared minus 4ac over 4a squared, like this. So that's the quick investigation. And we can also solve the questions by graphing the quadratic equations. Here again, ax squared plus bx plus c equals 0. Then let's suppose a is positive, the coefficient of x squared. Then the shape of the curve, the quadratic equations is open up and like this. And then this vertex point should be a minimum point when a is positive. If the coefficient of x squared term is negative, then the graph should be the other way, like open down. So it has a maximum value. I want to look at the vertex point here. This point is h equal minus b over 2a. Vertex line x equal minus b over 2a. Because here in this square form, it makes x equal minus b over 2a makes this term equal 0 if x equal minus b over 2a. So that And also the vertex line is kind of a symmetry line. The quadratic equation is perfect symmetry against this vertex line. So x coordinate, this vertex point, h equal minus b over 2a, and y coordinate, here this minimum value, that is b squared minus 4ac over 4a squared. Okay? And what is a quadratic equation? We already looked at that. Quadratic equation standard form is ax squared plus bx plus c equals 0. A could be positive or negative, but should not be 0. And usually quadratic equation potentially have two real solutions depending on the situation. You know, in quadratic quadratic formula, the value inside the square root sign, radical, depending on it's a real number or imaginary number. If this value is negative, then you get the imaginary root. Okay. So then and this quadratic equation usually we can find a physical example in the real world situation. For example, here modeling a dropped object. Suppose you drop an egg box from the height 200 feet, and you drop it, and after you drop that, each second, 1 second later, you want to find out the location of the box. After 2 seconds, you can see the height of the egg box, and the 3 seconds, after 3 seconds, you can find out the height of the box. So you have a locus, all this locus point, and you connect it. That shape makes the parabola. So that is the quadratic equation. And again, we're back to three different methods, right? Square root method and factoring method and the quadratic formula. So let's look at the square root method, square root rule. Suppose you have x squared equal k, then how do you solve for x? X equal, of course, you can take multiply the exponent power 1/2. Then that is x equal square root plus minus square root of k. And for example here, the equation x squared minus 4x plus 4 equals 16. Then in the right-hand side, left-hand side, you can square it, x minus 2 squared. That makes exactly x squared minus 4x plus 4 equals 16. So this form is exactly this square root rule. You can apply that. So x minus 2 equal plus minus 4. You can take a square root both sides. So x equals 6 or x equals minus 2. So same here example, 6x squared 96. Then you divide by 6 both sides. Then x squared equals 16. So this again square root form, square term. So x equal plus minus square root 16, that is plus minus 4. Same here, y square equal 40. So you you multiply by 1/2 power both sides, then y equal plus minus square root to 40. Square root to 40 is a square root inside the radical 4 times 10. So you can separate it, square root 4 and square root to 10. Square root to 4 is 2, so the answer is plus minus 2 square root to 10. So this is a irrational number. You cannot express this number in fractional term. So using the square root rule is very important. You have to transform the given quadratic equation into square form, and you can solve it or factory. Solving quadratic equation by factoring here, factoring quadratic binomial. For example, you want to solve 4x squared plus 8x equals 0. Then you can see 4x is the great common factor, the first term and second term. So you take out, you divide first and second term by 4x. So 4x, then x plus 2. This is factoring. So by multiplication property of 0, so either x equals 0 or x plus 2 equals 0. That way you get the solution, x equals 0 or x equals minus 2. Continue on factoring. Factoring is if x squared minus a squared equals 0, then you can factor it, right? X minus a, x plus a. And here, k squared x squared minus a squared. Again, you can factor it by like this, kx minus a. The first term, k squared x squared is the k square of kx. And a squared, second term, is square of a. So minus a plus a. So again, the first term, x equal a over k, that makes 0. And for second term, second factor, x equal a minus a over k. So we want to solve 49y squared minus 64 equals 0. Then you can do factory. 49y squared is a square of 7y. 64 is a square of 8. So 7y minus 8 and the 7y plus 8. So make it 7y minus 8 equals 0. Then y equals 8 over 7. And for 7y plus 8 equals 0, then y equals minus 8 over 7. So we have another question here, factoring quadratic trinomial, x squared minus 2x minus 15. We can factor it, the trinomial and left-hand side by x minus 5, x plus 3. So factoring is very important in solving quadratic equation or cubic equation, cubic function or polynomial function. Then set each factor equal to 0, and then you can solve. So x minus 5 equals 0, then x equals 5. X plus 3 equals 0, x equals minus 3. Another example here. What about 24x squared plus 52x minus 112 equals 0? So this is a large number, so it's not easy to get immediate factoring. Then try first simplify the equation. Here you see each term can be divided by 4, so you can factor 4 out, and the first term is 6x squared, second term is plus 13x, and third term minus 112 will be divided by 4 equal minus 28. So then now it's easier to get factor, to find out factor for 6x squared plus 13x minus 28. So 3x, 2x makes 6x squared, and 4 and 7 makes 28. But you have to be very careful where you have to put the plus sign and minus sign. So you adjust that, and you get factor 4 times 3x minus 4 and 2x plus 7 equals 0. So then first term 3x minus 4 equals 0, then x equals 4 over 3, that's the solution. And for 2x plus 7 equals 0, which makes x equal minus 7 over 2, that's the solution. But you cannot make a square root, and also you cannot factor it, then don't worry, you can use the quadratic formula. The quadratic formula is a wonderful tool to use when other factoring methods fail. When you don't find any factoring, and then just take that coefficient from the quadratic equation and plug them into formula. Formula x equal minus b plus minus square root b squared minus 4ac over 2a. So from ax squared plus bx plus c equals 0. And sometimes you have a rational solution, but sometimes you have irrational solution. Here, rational solution, rational number and the irrational number, what's the difference between them? Rational number can be expressed like a fraction, but the irrational number inside the square root, the radical, you cannot, if that number is it's not square term, then you have still square root a radical number. A radical number, if you have a radical number in the solution, then you cannot express it as a fraction like this. But this question, 40x squared minus 155x plus 125 equals 0, a equal 48, b equal minus 155, and c equal 125. You just plug them into the quadratic formula, minus b plus minus square root b squared minus 4ac over 2a. All right, so that 2a, a equal 48 here, and minus b is minus 155 minus 155, and b squared minus 155 squared minus 4a, a is 48, and c is 125. And then you simplify that, you get 155 plus minus 5 over 96. Fortunately, square root of 25 is a 5. So then you get the solution in fraction part, 5 over plus case 5 over 3, minus case 25 over 16. But by using this answer, you can do factor the 40x squared minus 155x plus 125 equal 0 it's like that, 3x minus 5 from the first solution, and 16x minus 25. So whenever you have factor terms, it can be not only just 2, 3, or 4 and 5 equal 0, you can solve it. Make each factor equal to 0. Okay, just previously I mentioned about the irrational solution. Irrational solution is unfactorification. So like here, the value inside the square root sign, radical, square root to 73 here for the question 2x squared plus 5x minus 6. This is an unfactorification. If suppose the second term is 4x, then you can do factor, but 5x is an unfactorification. So then by using a scalar formula, you just program all the coefficient of each term, and you get minus 5 plus minus square root 73. Square root 73, you cannot take out to get rid of the square root sign, radical sign. So you have to keep that square root sign. So plus square root 73 is about, you can calculate it by using calculator for 0.886, and for the case, negative case, minus 5 minus square root 73 divided by 4, that is minus 3.386. So this is unfactorification. So you get, and in this case, and you apply the square root formula, but inside the square root sign, the number cannot take out as a real rational number. So then you still keep that irrational number. Okay. Even when you see the higher order power, like G6 minus 26 G cubed minus 27 equals 0. It's not x squared minus 26x minus 27, but it's very similar. You can treat that like that by replacing x equals G cubed. G cubed, then you can put like this. Then you can do factory like this. So we let x equals G cubed, then G cubed minus 27, and x plus 1, and G cubed plus 1 equals 0. So you solve each factor by set 0. So G cubed minus 27 equals 0. G cubed equal 27. 27 is the 3 cubed, right? The power is 3. So then G should be equal, G should be 3, and G cubed plus 1 equals 0. Then G cubed equal minus 1. So minus 1 is the minus 1 to the cube, right? So then G should be minus 1. So it's not quadratic, but it's like a quadratic-like. You can treat that original problem and you can solve it. Here again, trinomial. quadratic like trinomial, y to the 4 minus 17y plus 16. But here we can factor it by using like y4 is y square and y square, and 16 is 16 and 1, so, and plus, so you get minus 17y, so then y square minus 16 and y square minus 1. But this y square minus 16, again you can factor it, y minus 4, y plus 4, and y square minus 1 term factor, you can factor it, y minus 1, y plus 1. So you have 4 factors, and you can solve by each factor set to equal 0. So y minus 4 equals 0, y equal 4, y plus 4 equal 0, y equal minus 4, y minus 1 equal 0, y equal 1, y plus 1 equal 0, y equal minus 1. Okay. Now, what about, so far we dealt with equality, quadratic equation, equality, equal 0, ax squared plus bx plus c equals 0. But what about inequality, like x squared plus 6x less than or equal to minus 5? So inequality, you see the inequality sign, less than, greater than, or less than equal, or greater than equal to. So this is a inequality, quadratic inequality. So how to solve this? It's the same method. So move all the terms to one side and to the left hand side. So then x squared plus 6x plus 5 equal less than, greater than, equal 0. Then you can factor it, x plus 1, x plus 5 less than, equal to 0. Then you find all the 0, meaning roots. So the first factor, x plus 1 equals 0, x equal minus 1. That's the 0 we call. X plus 5 equals 0, x equal minus 5. So then you put all the zeros in order on a number line. So this is number line. So minus 5 and minus 1. So we evaluate each interval, x less than minus 5, and the interval between minus 5 and minus 1, and x greater than minus 1. So you evaluate the sign for each factor. If less than minus 5, then the first factor, x plus 1, should be, it's a negative. And the second term, x plus 5, if you just plug x equal minus 6, then it's negative. So minus minus. But what about in the interval x between x equal x minus 5 and x equal minus 1, then first term x plus 1, if you just plug the x equals 0, then first term should be I mean 0, then no, not 0, I'm sorry, x equal minus 2, because we're looking for, we are in the interval minus 4 and minus 1, so that minus 3, then the first term minus 3 plus 1, that's minus, and minus 3 plus 5, then plus 2, that's a positive, so second term is positive. What about x greater than minus 1? X greater than minus 1, like let's put 0. 0 plus 1 equal plus 1, that's positive. And 0 plus 5, and 5 is positive. So this region, positive and positive. But we're looking for negative. So that when you look at the number of minus sign is even, then that makes positive, right? But here only one here in this interval, that's a sine line. So we create the sine line like this. Then when x is greater than equal minus 5 and less than equal minus 1, then minus plus. So then the answer is this interval, x minus 5 greater than equal and less than equal to minus 1, because we're looking for the expression to be negative. So this is sine line. You create the sine line. This is very handy to figure out the solution range. But what about the graphical method for solution x squared plus 6x plus 5 less than 0? First, we graph x squared plus 6x plus 5. We graph like this. The y-intercept is plus 5. And we know this graph, the x-intercept is minus 5 and minus 1. And we know this vertex is between this halfway. So, and then the coefficient of x squared is 1, so it's positive, so the shape should be open up. So we're looking for the interval x squared plus 6x plus 5 is less than or equal to 0. Then this is x equals 0, or y equals 0. So the y less than 0, that means this region. So that the shaded area, the color yellow, that's the region. So answer is x equal x minus 5, between minus 5 and minus 1. But that number should be included. So we use the bracket, the interval notation. And even this method, so we discussed so far, can be applied to higher degree of polynomial inequalities. So g squared minus 26, g cubed minus 27. So you can factor it like this. In the previous slide, I demonstrated that g squared minus 27 and g cubed plus 1. So two factors and less than 0. Then find out zeros. For the first term, g cubed minus 27 equals 0, g equals 3, that's a 0. G cubed plus 1 equals g equals minus 1. So that in the number line, minus 1 and 3, and we create a sine line here. For each interval, x less than minus 1, then makes minus 1, minus 1. The first term, minus 1. And the second term, minus 1. We just plug the minus 2 into g. And for the interval g greater than minus 1 and less than 3, then the first term equal 0. You just put the 0. 0 minus 27, that's minus. 0 plus 1 is plus. So minus and plus. If g is greater than 3, then first term, like you plug g equals 5. 5 to the cube is 125 minus 27, that should be positive. And g cube plus 1 also positive. So for this 3 different intervals, but you're looking for the expression should be negative. So that is odd number of negative sign. That is the region between minus 1 and 3. So that's the answer. So now we solve inequality x squared minus x greater than 12. Again, you move all the terms into left hand side, x squared minus x minus 12 greater than 0. Then you factor it on the left side of the inequalities. So this x minus 4 and 3, that makes it 12. So minus x, so minus 4. X minus 4 plus x plus 3 greater than 0. So for each term, make 0, then x equal 4. And x equal, for second term, x equal minus 3. Again, you put that zeros and put all the zeros in a number line, minus 3 and 4. And then you create a sign line. So x less than minus 3, x minus 4, x plus 3. In this region, x equal minus 5, then minus 5 minus 4 is minus. Minus 5 plus 3 is minus. So between this region, minus 3 and 4, then the first term, x minus 4, you put the 0 here, then minus 4. So minus 0. Put 0 in the second factor, makes 3. So plus. If x greater than 4, then you put the 5, here x equal 10. 10 minus 4 is positive. 10 plus 3 is positive. But you're looking for positive, right? The expression. You want to find out the interval that makes whole the quadratic positive. So then positive is this region minus is a even number minus sign that makes positive. Even number positive sign that makes positive. But this one is odd number that makes them negative. So that the answer is x less than minus 3 and this region x greater than 4. So that by using interval rotation x less than minus 3, then minus from minus infinity to up to minus 3. So minus infinity to minus 3. And for this region, x greater than 4, 4 to the infinity. So then 4 and infinity. So that's the region. So this is how we can solve inequality questions. What about if you see the fraction inequality questions? That's the same. Here you find all zeros, x minus 2, then x equal 2. X equal minus 6, x plus 6 equal 0, then x equal minus 6. So I know the denominator should not be 0, right? So, but just to create a number line and sign line, to do that, we just using the zeros, x equal 2 and x equal minus 6. So x less than minus 6, then here minus the numerator minus 7 minus 2 minus 7 plus 6 minus, so minus. Between this region, between minus 6 and 2, the numerator is 0. If we put the 0, 0 minus 2 minus. If we put the 0 in denominator, 6, so it makes positive. X greater than 2, so 3. You just plug that 3 into x. 3 minus 2 equal 1. 3 plus 6, 9, positive. But it should be, you're looking at the interval that makes the expression negative, right? So then you see the number of negative sign is an odd number. So this is a region. This is the solution. X minus 6 and 2. Minus 6 greater than or equal to 2. But minus 6 should not be included. That's why we put the open parentheses. And 2 should be fine. In the numerator, it could be 0. So we bracket. You use the bracket. So other range interval here, minus minus. That makes positive. Plus plus, that makes positive. So only between 6 and 2, that's the region, that's the interval, which makes the inequality negative. Okay? Or if you have many factors, the same, they can be applied like a polynomial function. You can see many factors. X plus 2, x minus 4, x plus 7, x minus 5 square greater than or equal to 0. Then you find all zeros is a root, then and you create a number line by putting all the zeros in order. So minus 7 and minus 2 and then 4 and 5. And then you create the sign line. So each term, if x less than minus 7, then all negative this term. But only this x minus 5 square is any number can make positive, right? Or 0. So then plus. So between 7 and minus 2, the first two term, if we put the minus 5, then minus 5 plus 2 minus 5 minus 1 minus 9 minus. But third term, third factor, x plus 7, x minus 5 plus 7 makes positive. Minus 5 equals 0, that's positive. So minus minus plus plus. What about this interval? Minus between minus 2 and 4, minus 2, you take a 0. So 0 plus 2 equals 0. 0 plus 2 equals 2, which is positive. And 0 minus 4, that's a negative, so negative. 0 plus 7, that's 7, positive, third factor. And the 0 minus 5, positive. So positive minus positive, positive. But what about between 4 and 5? 4, if you put 4.5, you plug that 4.5, that makes positive. 4.5 positive, 4.5, that makes positive. So positive, 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 positive. What about x greater than 5? That makes all positive. So the expression should be greater than or equal to 0, so positive. So you're looking for find out the interval region, interval which has even number of negative sign. So this is an odd number, negative sign 3. This is an even number, just 2 negative sign, that makes positive. So here you see only one negative, that makes negative. And this between 4 and 5, all positive, so that makes positive. Greater than 5, that makes positive. So the answer, the interval x, this is the solution. So x minus 7 less than equal to 2, minus 2, and x greater than 4. So that's the solution. And by using interval notation, 7 minus 2, between 7 and minus 2, all the number can be included. So bracket. And 4 and 5. 4 greater than 4 or equal to 4, and then to the infinity. So then bracket 4 and infinity parenthesis. Okay, so this is the subject that we have discussed, how to solve quadratic equations and quadratic inequality. Thank you for watching. God bless you.